Welcome to Psychiatry Grand Rounds. This morning I have the pleasure of introducing Dr. Alyson Chroust. Dr. Chroust completed her bachelor's degree in psychology and biochemistry at Simpson College, her master's degree in experimental psychology at University of Kentucky, and her PhD in experimental psychology, cognitive and developmental sciences at University of Kentucky. She is currently an assistant professor in the Department of Psychology at ETSU. Please join me in welcoming Dr. Chroust.
Hi guys, Happy New Year. Good, happy to be here, kind of stepping out of my realm within the Department of Psychology and over to our siblings over here in Psychiatry. It's very cold, so I'm glad you guys made it out here today into this warm-ish auditorium. Thank you for that introduction. I'm going to be talking today a little bit about the research that I do and what work that I'm hoping to continue here at ETSU. And so hopefully I'm translating it in a way that it's more interesting to your field than just kind of where I come from and how I approach my research as a basic researcher, where I'm just trying to answer questions like what is developing and when. And it's a little less focused on the applications, but I'm hoping that once I can lay the groundwork with some of these basic research questions, once we get those answered, then we'll be able to translate it into applicable work towards interventions. And that's where hopefully I can work on these collaborations and different types of projects to work on designing those. Okay, so a little bit of footwork first. I need to cover the bases here and let you guys know that I don't have any sort of financial interest or arrangements. Kind of more going on those. We'll just cover here. Okay, all right. We've got that covered. And then I just want to start out now and acknowledge some of my collaborators from the University of Kentucky and some of our funding resources during my time at UK as well that supported some of the research and the data that you're going to see here today. All right, to kick things off, kind of an outline for my talk today, I'm going to start by introducing some concepts of social and visual cognition in developmental science. That's the type of research that I conduct with infants, so I'm interested in learning within the first year of life, what do infants know about the visual world? How do they explore people and faces and learn to recognize different emotions in those stimuli? So I'll give you a little bit of background to help frame some of that research, and then I'm going to jump into discussing some of the methods that are used for assessing social and emotional development in infants. And I think this is really critical because it's one of those things that we know is very important to later development. It's going to help lay a strong foundation for attachment and later relationships, but it's a topic that can be kind of hard to measure in the population that I'm interested in, infancy, so between 0 and 12 months, and sometimes even between 12 and 24 months, those first couple years of life. So I'll go over a couple methods that can be used to do that, and then tell you why I think one of the measures that we use in infant cognition could be really helpful to add into that arsenal of tools. And then finally, I'm going to wrap up by talking about my dissertation, which compared the cognitive development of opiate-exposed and non-opiate-exposed newborn infants. So the newborns that I studied were anywhere from 12 hours old to a couple weeks old in the case of some of the opiate-exposed infants. So it's technically not newborns, some of those were, but that's the population we'll finish up with. Okay. All right. Very broadly, social cognition as a field is going to concern how we process information about, how we make inferences about, and remember people. Processing information from social stimuli, so those are going to be things like faces and whole people, like I mentioned before, is an important aspect of social cognition. The way we process information like that is considered to be specialized by a process that's facilitated by our tendency to attend to this type of information very early in life, the high social relevance that it carries in our society, and our repeated exposure throughout our lives. And so as adults, this tendency to attend to social stimuli really helps us to be able to quickly identify and remember, kind of, and recognize countless numbers of individuals. And we can even remember details about those different individuals, like emotions, their race, their gender. We can identify those things very quickly and very accurately. It's also an interesting topic as a developmental psychologist because It has a unique, because of this repeated exposure, it's very unique to infants because they're drawn to those stimuli from a very young age. We know that newborns will turn towards pictures of faces or real faces longer than they turn to other equally complex stimuli. So there's something about the structure of those stimuli that are capturing their attention with very, very little experience in the world to see those stimuli. And it's thought that this really early experience, this sort of tuning towards social stimuli, provides the experience necessary for us as adults to develop that expertise and that specialized processing that we have. So what we want to do, that's kind of social cognition in a very broad sense. And what we try to do as a field is that once we understand what's necessary for us to be able to function in our social world, we can then apply it to documenting or potentially diagnosing some of these developmental disorders. And we always want to try to diagnose those as young as possible, so there's a big push to understand what those processes look like at the very youngest age. So I told you I was going to try to focus my talk on social and emotional development, which is fairly easy because a lot of the topics that I study are social in nature, and of course they come with a little bit of emotion topics with them as well. But why this is critical for us as a field to be interested in the first place is that social and emotional development is going to lay a foundation for later development in almost all aspects. We are seeing a growing emphasis from policymakers and practitioners for wanting to focus on understanding social and emotional development in infants and kids. There's the infant mental health group that's really interested in understanding some of these reciprocal relationships between the infant and the caregiver, and all of those are going to have a home within the field of social and emotional development. The biggest challenge of some of these initiatives and these efforts that are coming forward is it can be a hard topic to measure. And so that's what I'm going to try to put forth, or what are some available methods right now on ways that we can measure social and emotional development in infancy and early childhood, and what are some of the strengths and weaknesses of those measures. So here's just a breakdown of during infancy, so again, 0 to 12 months, what are we typically seeing in children or infants as they're developing or acquiring these social and emotional skills. So for example, you're seeing that babies are becoming aware when they're separated from their adult caregivers. That separation, they're becoming aware of that distance and oftentimes unhappy with that separation. Infants are also learning to be comforted and soothed by their caregivers, and as that comes, as they're learning how the caregivers are then soothing them, they're then learning how to self-soothe. That's the aspect of kind of self-regulation coming in. They're learning how to self-regulate their emotions. They also begin participating in social interactions. They're smiling, they're cooing back and forth with their caregiver, so that's the exchanging vocalizations. And they're expressing a variety of emotions, so from happiness to sadness, fear, and also anxiety during that separation time most often. So just like social cognition is multifaceted, so is social and emotional development. There's a really nice review paper that's identified kind of these 4 key areas or kind of subscales within social and emotional development. So we've talked about social competence. That makes a lot of sense given the name of the area. Emotional competence. And then you've got behavioral problems that can be observed. Oftentimes you're going to be seeing these in older kids, so 3 to 5 years of age. And self-regulation, so an infant and child's ability to regulate their own emotions. They also mentioned executive function, and I always like to throw this in as an important subscale too, because we know it's got very important implications within the field of cognition and within emotional processing as well. So I don't want to leave that one out. So here finally some of the scales that this meta-analysis extracted as the best 6, or I guess the strongest psychometrically 6 subscales for measuring social and emotional development. So the only one that covers kind of specifically 0 to 3 was the infant-toddler social emotional assessment, and then we've got 5 others appropriate for the ages from 0 to 5. These were considered the strongest measures because of the quality of the measures, so they were found to be the most reliable and the most valid. It took the least amount of time to administer these 6. We know that the time that it takes to administer is something that's really key to consider when we're talking about surveys. How much does it cost to implement? what's the age that's included within there, and then the kind of availability of the norming and validation data. So those are kind of the best 6 that were pulled out from what's available. And just to give you a brief example of what some of those scales look like, so within the infant toddler social emotional assessment, there are 4 large domains, and competence is one of those as an example. And within those 4 domains, there are 17 different subscales. So you can see examples of the attention and the compliance subscale here, just to give you an example of some of these questions. And so if we just read a couple of them, so looks at picture books by himself or herself, sits for 5 minutes while you read a story, all fall under the attention subscale. Let's see, if we look at the compliance, quiets down, tries to do as you ask, is well behaved. So these are all things that either a parent or a child care provider is going to fill out, a survey style report, and answer the questions. This is an example of something that's a lot shorter. It's the BASC-3, and so this is going to basically assess a wide array of behaviors, behavioral problems, and strengths. It can be completed a lot faster, and it can be done by a teacher, the student, or a parent. Again, some examples of some of the items you may see there. And then the final example I have is the child behavior checklist. Again, this is a parent item, has a total of 112 different items, lots of different sub-areas, including social withdrawal, anxiety and depression, destructive behavior, attention problems, delinquent behaviors. And so those are just, I kind of want to let you see some of those. And remember, these are supposedly appropriate for kids ages 0 to 5. This is what's available as far as social and emotional development, some of the top psychometric properties. And this is kind of just my personal opinion, is that knowing, with my experience studying infants from 0 to 9 months old, a lot of the measures, or a lot of those items within all those different assessments aren't necessarily appropriate to ask of an infant who's 0 to 12 months of age. Or if they are, you're going to have a lot of holes within those items that you're not able to complete because they're not applicable. And so how impactful is that measure or the scores you're getting from that assessment for that specific age group? So while it's been normed and validated to be used for that age range, what is the real impact from those? So I think we can do a little bit better. Now, these are great because they're surveys, right? They're large-scale surveys that have normed data, so they can be used in a variety of populations at a variety of sites relatively easily. But unfortunately, because they have some of those items that aren't as impactful for certain age ranges, what does that data mean? What is that information? Is it really helping us understand their social and emotional development for that first 2 years, especially that first year? So what I really want to focus on today is maybe an alternative method or an additional method to considering social and emotional development. And while this is all based on observational data, this is going to be something that can hopefully capture a more accurate picture of emotional processing and emotional development within that first year. So just as a recall of what we're considering, how we're defining social and emotional development, we're talking about their experience, expression, and management of emotions, and their ability to have this relationship, the positive relationship with others, so oftentimes they're caregivers early on. And what I really want to focus on is this line here. So research is always going to show infants are able to experience, express themselves, and perceive emotions before they fully understand them. And this is something that I always end up kind of fighting when I come to give talks is, I present this information that 5-month-olds are sensitive to this type of emotion in faces, and people look at me like, well, that doesn't mean that they understand those emotions, all the meaning that we carry when we see a fearful face. We're not claiming that the infants are understanding that to the same level we are as adults, but they are still perceiving something, that first critical step in a fearful face that makes them, look at that different than they look at another type of face, say a happy face. So they're picking up on some subtle difference, which is, it's just a perception. We are implying some type of understanding, but we're not claiming that they've got an adult-like full understanding of what that emotion means, what that carries with them. But it is how we all need to start off, right? Baby steps. Okay. So why do I want to study infants, right? Again, we all have our different age groups of our preferences, and I've just enjoyed studying infants. That's where my experience is so far, and it's because of my interest in basic science. I'm really interested in understanding the nature of processing. So those are going to be asking questions like, what kinds of information are infants processing? What types of features are they able to pick up on? So can they process subtle spacing differences between two faces? Are there specific brain regions devoted to certain types of information? So once we have an idea of these nature of processing questions, so once we understand what skills are developing, what abilities develop, then we can work on understanding the mechanisms behind that development. So what mechanisms underlie those different skills? Are some effects more apparent in infancy than later in life? What are driving those skills? So during this earlier time in development, infancy 0 to 12, instead of using survey response formats where parents or caregivers or maybe even the child itself towards some of those older ages are completing the measures, what we can do is use a more interactive method. So by observing infants' looking behavior, so by watching their eyes and where they choose to look, we can understand, or how they're interacting in a play period or with a caregiver, we can understand some of these social and emotional skills that are beginning to develop. And one of those is going to be the still face paradigm. And that's kind of what I've got broken down here on the slide in these kind of images. So the still face paradigm has 3 different segments. So there's going to be a first period here called the play phase, where you have a caregiver kind of just interacting, playing face-to-face with their infant. And then we go into this, what's called the stress induction phase, where the caregiver all of a sudden freezes in a dead gaze, locked eye contact with their infant. Now during this phase, they're instructed not to interact at all. They can't respond to their infant's cues or cries. They just have to stay for this kind of 3-minute period locked in a still face stare with their infant. And then once that time period is up, we go into the reunion phase where they're able to comfort and care for their infant again and then interact just like they were during the play phase and hopefully help their infant regulate back to a normal state. And what we're interested in during this task is, what does the infant do, right? They're very happy during the play phase, nothing's wrong. They become then they become very distressed during this period of still face, right? They are still, depending on their age, they're still learning those self-regulation skills. Oftentimes they rely on their adult caregiver to then do that regulation for them. So when that stops during still face, it's very, very concerning for them. And so you see a lot of expression of negative affect and gaze aversion away from that locked eye contact. It's very uncomfortable for the infant, but not harmful in the long term, right? And then we have this period where we reunite with our caregiver and we're able to play, and we see that everything kind of comes back to the baseline. And so this is a really useful paradigm to understand self-regulation skills in typical and atypical populations. So we'll kind of return to that a little bit at the end, but that is an option that I think gives a little bit more insight than some of the survey-based research, so either to use this in combination with some of those surveys, or just interesting to stand on its own. So you also have gaze cueing paradigms. So we can look at how they respond to different faces. So again, remember, I'm focusing on how infants look at different types of social stimuli. So these are images presented on a computer screen. The infant, we're watching their eyes and where they're gazing. And so we see just Elmo there in the middle, grabbing their attention, telling, hey, look at this, something's gonna happen here, I want you to direct your gaze here. And then the study will start where you see an emotional face that has kind of direct gaze, so it's looking straight at the infant like it was during the still face paradigm. And then what happens is you see a shift in the gaze to either the left or the right, and the target will either which is kind of that top, spinning top there, either appear on the same side as their gaze or on the opposite side. And what we can do is measure how long it takes them to reach that target and see if you're getting differences based on when it's been cued by gaze versus when it hasn't. And this is just, I think, a really cool task to use when we're looking at social emotional processing, because you can vary the emotion of the face presented and see how that impacts the infant's reaction. And additionally, what you're looking at is the eye contact that's happening. So we've got that direct gaze phase, and we know that the eyes are a way where we portray our emotion very easily. We get a ton of information about emotion from the eyes. So you see the eyes get really wide and bright, white here during fear, whereas during happy it's a little different. So we can get a lot of information about emotion from the eye region. They're very good at expressing different mental states and kind of our desires as well with that gaze direction. So this is something that we can use to look at the task of joint attention and how we learn to kind of automatically orient in the same direction as somewhere else. So again, working at the attention component here that's required for good relationships with caregivers later on. Finally, I'm going to present on the visual paired comparison. And right, you always leave the most exciting for last. So this is the one that I focus on and that I use most commonly in my work. It's the most simple, I would think. It's basically, sometimes you'll hear it referred to as the novelty preference procedure. But what it involves is, I'll kind of get into here in a little bit, but I guess I'll get into why it's important first. It's going to capitalize on one of our kind of fundamental biological abilities, and that's our ability to detect and respond to something that's new or novel in our environment. So what they're going to see is how long it takes them, or will they kind of be able to detect that new or novel object that's been placed in front of them. And it's also, like is mentioned on the slide, it's really helpful because it's associated with later cognitive functioning and intelligence. So we know it's got some sort of predictive validity going on. We're able to see it's related to some sort of academic functioning later on. Okay, so here's what it's going to look like in a very simplified sense. You're going to have a period of habituation or familiarization, and that's just going to include this repeated exposure to a stimulus. Doesn't really matter what the stimulus is. You can vary that based on your research question. And so for in this example, we just have this repeated exposure to 2 green squares. Okay, so imagine you're looking at these for a specified amount of time, and then what will happen is you'll go on to the test trials. Okay, so the test trials are going to be the simultaneous exposure to something that's familiar, right, that green square we just saw, and then this novel stimulus. And what this procedure is hoping to capitalize on is looking longer towards what's new or novel. So here, hopefully, you guys are all looking longer towards that red square. Captured your attention, it's different than what you saw. And then with this procedure, because we're using infants, we want to make sure that it's not something, their looking isn't based on the fact that they like to look just to the right of everything. So then we'll always make sure that we counterbalance the side of the location of that novel object across our test trials. So you'll just see them flip-flop or kind of progress in a randomized manner depending on how many test trials there are. One key thing I do want to mention here is our dependent variable. So what we're interested in measuring using this method is going to be their looking preference towards the novel stimulus, like I mentioned, that red square. And what we're seeing is if that novelty percent preference is significantly greater than 50%, then we are inferring that they're recognizing that novel image. And we use 50% as our comparison here because there's 2 options of things to look at. So you have if they really have no preference, then they should be looking 50% at each item. If they're able to recognize that, they'll be looking greater than 50%. Okay, so here's what the setup may look like in a research lab that's using the visual paired comparison. You'll have an experimenter back behind a curtain running all the computer programs and everything there, and then you'll have a caregiver and an infant sitting on the other side of the curtain where they see 2 computer screens set up side by side, or just one large computer screen with an image on the left and an image on the right. And then there's usually a video camera up here or on the bottom in the middle, and what that's doing is recording where the infant's looking. And so the infant just gets to sit on mom's lap mom or dad, and the caregivers are just wearing basically glasses that have been blocked out so that they're not able to see the images on the screen, so they can't influence where the child may be looking by giving them a little twerk one way or the other, because the adult can tell the difference between the test images. So that's a basic idea of what they're seeing. And so here's an example that I've got from an infant that's participated. So you can see we're just kind of looking in the middle, and you can see test trials have now started, and you see the infant's gaze shifting from the left and the right, back and forth, as they're examining the two images, the test images that have been placed on the screen. And so it does take some practice to be able to code these, but it's a very simple, very harmless task. All we do is sum up how long they're looking to the left versus how long they're looking to the right. And that's how we're able to then get that novelty preference across all of our different test trials. The infants really love coming in and doing this. It seems to be a fun process to look at these new stimuli. They get to interact with new people. So I usually don't have too difficult of a time recruiting families to come in and help. And it's always fun. So anyway, there's an example of that. Let's see if I can get on to my next slide. There we go. Okay, so let's talk about we saw what the baby looks like from a researcher's component. Well, what would the baby be looking at? What are some things that we found that infants are able to do using this procedure within the first year of life? A lot of this is going to focus on even within the first 6 months of life. So using faces, one of our favorite social stimuli, something that we as adults are very, very familiar with and are experts at processing, we found that even infants as young as 5 months are sensitive to these subtle spacing changes in faces, which is that mark of expertise in adults. So if you look at the sample faces here, we've got, I call this a normal face, but in reality it's just the original face. And then what we've done here is we've made 2 types of spacing changes. We've changed the distance between the eyes and the distance between the nose and the mouth. But this face on the right is still within the spacing arrangement of features is still within someone that you could encounter on the streets. We haven't made the spacing changes so extreme that it just looks like it's not possible for you to run into that individual. And so what we find is that using this visual preference procedure where infants look at one of these faces, learn about that face for a period of time, and then they're tested with these 2 faces side by side, what we see is they look longer to the novel face. And it depends on whatever they're familiarized to. It goes both directions, so it's not just a spacing change kind of preference face. They're able to look longer at that novel face, which is really spectacular and was pretty groundbreaking to show up that this is available by 5 months, because it's considered that mark of expert processing that's thought to be due to the extensive experience that we have with faces. But evidently, 5 months or even 3.5 months in some cases is enough time and enough experience with faces to demonstrate that ability. So we've got this fun skill with faces that we see within the first 5 months. You can do something similar with bodies. So we found that if you have 2 different body postures and you use the same sort of procedure, you familiarize infants to one of these body positions for a certain amount of time, and then you test them with these 2 pictures. And the only difference between these pictures is the location of one arm and one leg. You'll see that infants look longer to that novel body posture than they did to the one that they were already familiarized to, indicating that they are sensitive to that difference in the positioning of body kind of limbs. And this is by 5 months. So getting into the emotion component, not just the social stimuli component, we've even found that infants are sensitive to emotions in body actions. So what you see here is you've got a happy individual here on the left and an angry person on the right. Fingers crossed you guys were able to do that without my cues, right? We're hopefully good at this. But they can be kind of difficult. So the infants actually saw videos, not just these still images, so it's a little bit more informative than what you're seeing here today. So you see someone kind of jumping in the air for joy or kind of raising their fists, shaking them in anger. And it's played with a vocalization as well. So it's played with someone who's kind of giggling along or someone who's growling in anger. It kind of goes grrr over and over again with the angry video. And what we did is we looked to see if infants would match. So do they look longer to the angry video when they hear someone growling at them? And then do they look longer at the happy video when they hear someone kind of giggling? And we found that by that skill develops within 3.5 to 5 months of age. So our 5-month-olds were able to match the vocalizations to the visualizations of emotion, but the 3.5-month-olds were not. So we see that that's something that's coming online between those two age periods, which is just a month and a half. So it's something either with experience, we're not quite sure. That's what I'm trying to hopefully dive into a little bit more here and see why that's something that's coming online between those two ages. We also know with faces, this research is a little older with the emotional faces, that infants prefer certain emotional expressions over others, depending on how old they are. So it kind of flip-flops. They prefer happy at some times, they prefer fear at other times in development, but you will see that they're able to discriminate between those emotions in faces. All right. And so this is using a little bit of that gaze task idea. This was done on an eye tracker, and we're looking at attention processes along with emotions. So we have 3 different emotional faces that appear in the middle. So we saw a happy trial, and then a kind of target popped up on the side. There's a fearful trial with a target on the side. And then this should hopefully be the neutral if I pulled this video right. And you see we've got a target on that side as well. And so what this whole task did, there were 36 total trials per infant with those 3 different emotions or expressions kind of randomly rotating, the target presentation on the left or right being randomly presented as well. We ran 2 different age groups, 3.5 and 5-month-olds, and actually were able to find what in the literature is called this fear bias emerging at 5 months of age. So that's letting us know that by 5 months, infants are showing this attentional bias towards fearful facial stimuli, these dynamic videos of fear, based on how long they're looking towards that fearful face in the presence of that competing target. So you see during those trials, there's a 3-second time duration where the face and the target are on at the same time. And so during that time period, we're looking at how long did they look towards the face versus how long they looked towards the target. And for the fearful trials, this is what this bar is showing, is they looked longer towards the fearful face in comparison to that target than they did in the happy and the neutral trials. So those are both different, significantly different. And this matches on with some previous literature that documented this fear bias emerging at 6 to 7 months of age. But those studies were using static images, so pictures. So when we're increasing the ecological validity of the stimuli by using something dynamic, which is more similar to what they're encountering in their daily lives, we're able to see that this fear bias actually emerges at a younger age. Really showing the importance of making sure the stimuli that you're using to test are as valid as possible. So we were able to document that, which is really cool. So to kind of summarize what we found was some of those typical developing infants with their kind of social emotional development, we're seeing that they're able to process these subtle spacing changes in faces and bodies, and that they can perceive emotion in faces and bodies. So in my opinion, and I'm biased, right, because this is the research that I do, this is more informative to that age group of 0 to 12 months when it comes to their social and emotional development. We can see specific tasks that they're able to complete in the time course of development in which you would expect to see their ability to do these sort of things come online. And so what I hope to do is use some of this information that we know about typical developing infants and their emotional abilities, their perception of emotions, I guess, and apply them to populations that are, at risk for poor emotion development. So in this region, what I'm hoping to do is study that with opiate-exposed infants, right? So opiate exposure has an impact on a lot of different aspects of development, but one of those aspects is likely their social and emotional development with their caregiver, that bond. And so if we can study these aspects of emotion in strangers' faces or their caregivers' faces, we may get a better idea of what some of those deficits are and how we can maybe intervene a little bit better than just documenting, yeah, they have poor attachment. And often, well, again, because we can't do attachment measures until they're a little later. So I'm hoping that we can get some really specific findings here within that population of infants that will help us design these interventions and answer those kind of what is happening questions first, using these different measures instead of just the survey-based research, but it could be used in conjunction with those measures as well. Okay. So if we kind of jump back or shift gears, I guess, a little bit to the opioid group and studying opiate exposure in infants, I just kind of want to transition into the fact that a reminder that I am a developmental psychologist, so my goal is always to go as far back in development as I can to try to document these abilities and when they emerge. So because I was finding some of these skills emerging around 3.5 months of age, I decided that I needed to go even younger. So this is where I got interested in studying human newborns and actually getting involved within the mother-baby unit within the University Hospital at Kentucky. So I was actually able to work with a couple pediatricians and research nurses there, where I was able to get into the NICU and the kind of mother-baby unit and study infants within their first few days of life, which was a really unique experience, and just to kind of to show how cool that was and what I'm hoping to eventually bring here. It was the only lab in the US that was doing that type of research. Usually all the work with newborns that you see coming out in papers, if you're seeing them, are all coming from the UK. So it's a really remarkable thing if we can get that going in this region again. So what I was able to do is apply that same method. So again, these newborns aren't able to talk to me. The parents don't have a lot of experience with them to be able to answer some of these survey questions with, but they can see, and they can use their eyes to tell me a little bit about what they're understanding or how they're learning about the world that they've just been put into. So using that same method of a simple video camera and 2 side-by-side images, this is an example of a newborn. So you saw a 9-month-old earlier, and this is a newborn. So you can see there are some pretty extreme differences. The eye movements are slower, right? The fixation shifts side by side are a little slower. It's a little harder to detect exactly when they're on the left or right, so your experience coding needs to be a little bit more advanced, but you can still see shifts in attention. You can see them looking from the left and back to the right, staying on one side longer than the other. So it's a method that can be used with this age group. So it took me a while to work out a couple kinks, right? A new age group, new settings that's a little bit more variable, but we were able to replicate some older findings with newborns to know that our process was working, and then we were able to set out and answer and try to ask our new questions. So we did research with typical newborns, so non-exposed infants, and we also worked with opiate-exposed infants to start out. You guys know about the prevalence rate of opiates here in Tennessee, and the prevalence rate in Kentucky is about the same. It's a little less, but these numbers are a little old, but you see that it's still on the rise, so it was an important group to look at the time. So my goal, what I set out to do was examine their perceptual functioning using this novelty preference procedure, something that hadn't been done yet with this specific group. But when it came time to narrow down exactly what research question to start with, that was slightly more difficult because there was no previous work using this method. So I turned to what had been done with substance abuse on cognitive development in infants and children, and to try to help me find a task that I would design and guide my hypothesis about what would be disrupted based on prenatal opiate exposure. That literature review basically led me to these different measures of cognitive and neurobehavior within the first year. So the Bailey, the Griffiths, and the ENDS. The Bailey is the most common, but what you see is it's applicable for infants 1 month to 42 months of age. But when you look at the age groups that it's most commonly reported in, it's actually most often assessed for the age groups of 24 to 42 months of age, which is outside of the age range that I really want to study. And if you talk to practitioners, you'll hear them say that no one really likes the Bailey within the first year. It's not as reliable. You know, it's great that it can be used there if you're trying to do longitudinal work. You can see that individual change. But if you're just looking at those time points within the first year, it's not that great. It's kind of the best of what we have, but it does have those limitations. And again, these are all great because they're large survey-based studies. You get a lot of information out of one, and they're designed to be used repetitively over time. But again, you're getting these big measures of, yes, there's a cognitive, the Bailey will maybe show you you've got, a cognitive delay. Okay, well, what kind of cognitive delay, right? What aspect of cognition are you going to target to try to help that individual, right? So there's some subscales, but again, the measures within the first year of life are not great. So for me, the data that I see from the Bailey that's reported is showing, yeah, these infants have a cognitive deficit at this age. That's like bringing your car in and the mechanic being like, yeah, there's a problem with your car, and that's all you get, right? Well, what's the problem with my car? How do I fix it? Well, I don't know. I need to run like 10 more diagnostic tests, right? So they run those extra tests, and then you have a better idea of what's actually wrong. And so that's what I think needs to be done. So we see the Bailey, we see this basic deficit. What are those specific diagnostic tests, or what are those specific skills we can do to understand more about what that delay may be? So that's hopefully what I'm going to get into. These are some of the consequences that have been documented within the human literature and the animal models. You see some poor motor development. Again, the very broad lower language and cognition scores. And then within the animal models, that's where I really started. You see these impairments in spatial and recognition memory. So that's where I decided to kick things off. We can do some work with spatial processing using the visual recognition procedure. And we know that spatial processing is something that's really integral to later performance as well. So it had an importance of understanding the spatial skills too. So we're going to look at spatial processing within these two populations. So here's a very basic spatial task that's been used with infants and adults, kids, before. What you're doing is looking at the relationship or the spatial location of these 4 dots in relation to that horizontal bar. So again, let's say you're familiarized to those 4 locations before you start, and then at test, you're tested with this spatial relation and that spatial relation to see which one's novel, right? So technically, they're both novel locations. Which one's more novel? All right, back on. Okay, so I'll try to get through this so we see that this guy is more novel. So we would expect infants to look longer at that spatial relation, that above-below relation to that horizontal line. Those are pretty boring, right? Non-social, no one's very excited by those. But you can do the same thing with social stimuli like faces. So these are similar to those images or the faces you saw earlier when I was talking about changing the relation or that distance between the eyes and then the distance between the nose and the mouth. All we've done here to help our newborns is remove those external features, which can be really distracting to newborn babies. They prefer to look at hair, ears, instead of focusing on those internal features unless you force them to. So that's all we did here is we forced them to focus on those key internal features by removing that distracting information. And that's what we're going to show them. So this is my step to prove that those two faces are in fact different. If I put them on top of each other, you can see that the spacing changes are changing. So there is a difference, a very subtle difference, but there is a difference. So what did I do for my dissertation? I'm running kind of short on time, so I'm going to try to cruise through some of this background. We did some screening to make sure that we were getting healthy babies, even though they were exposed. So they were all had APGAR scores of at least 7 at 1 in 5 minutes. They were all carried to at least 37 weeks gestational age. They had known prenatal opiate exposure. So we didn't run any types of opiate kind of drug screening tests ourselves. We were just relying on the medical records to give us that information for enrollment. So the mother either admitted to use during pregnancy, had a positive screen during pregnancy or delivery, or the infant had a positive urine or meconium test for opiates. So that's how we relied on an infant being exposed or not exposed to an opiate. They had to weigh at least 2,500 grams. Moms had to be at least 18 for consenting purposes, and no other really medical concerns. So here's exactly what they saw. For 30 seconds, they were familiarized to the same face on both sides, so it didn't matter what side they were looking at. They were able to learn about all these relations, study the face, take it all in, whatever they could pick up. We did use female and male faces both, so that's why you're seeing an example of a male face that was used. They look at that for 30 seconds, they get a break, this attention getter to focus their attention back in the middle of the screen would come on, and then they have 2 8-second test trials where they see a face that they saw before paired with one that they didn't. This is the spatial change face, and this is where we're looking to see if they'll look longer at that novel face. And then, like I said, we have a break again to recenter their attention, and then the faces switch locations. And we'll measure how long they look to both faces. We also had half of the infants that were enrolled did a basic spatial task. So similar to that above-below that I showed you, they're doing a left-right spatial task here with just basic shapes. This was to see if there are any potential differences between social and non-social stimuli. We thought that maybe social stimuli, their processing would be more disrupted in the opioid kids because they would have less experience with faces, perhaps. And you'll see later on what we found with that. So I like to put this in because I say I'm studying newborns and their visual perception, and you guys all have training in what newborns are able to see. And we all know that it's a lot more limited than what we see. So here's a normal image, and here's how their infants are going to see that in this study. So it's going to be blurry, right? But you can still make out these different features, right? So they do look like kind of just gray and white blobs that are put in, but you can still see spatial arrangements between those blobs, if you will, at that distance of 30 centimeters, which is how far the infants were away in our study, and the images are kind of created to be the right size, so they're able to see them to the best of their ability. So they're not seeing like you and I are, not picking up on those crisp details of a face, but they can still make out differences between them. So this is what my group looked like. I had 32 opiate exposed and 32 non-exposed. My biggest difference you see between here was their age in hours. This was, at the time, out of my control as a researcher and something that I'm going to work to control better. So my non-exposed infants were only in the hospital for 3 days with their parent and with their families, right? Then they get discharged. My opiate-exposed infants were in the hospital a lot longer because they're being treated for withdrawal. So I was able to capture them at later times. So yes, they are significantly older, but what you see in the analysis that I've done is that I've controlled for those differences in age, and anything I'm finding is controlling for age. This is the data that we've got. So that's something that I would like to be able to actually design and control and match better in the future, and I kind of acknowledge that's a big limitation of the recruitment I've done here. Okay, let's see. So we've got that, and then here's some of the characteristics of the moms in the group. Slightly older group for my non-exposed, and the normal differences you would expect as far as SES, education and employment levels. So again, something that ideally I would like to recruit matched samples, but this can be difficult to do depending on how you're kind of doing this recruitment. And as this was a pilot study, the first one of its kind, I've learned a lot from this first step onto how I want to improve on things. But again, these are, if there were significant differences between my groups, I statistically controlled for them in my analyses. But again, ideal world, you'd like to do that with your design and not with your statistics. I've got a wide variety of opiate exposure. I didn't exclude patients based on what type of opiate exposure, polysubstance. I kind of took anything and everything I could find. So this is the variety that we're seeing. The highest percentage there is the buprenorphine. So here's the data from what I found from my study. What we've seen is we've got our faces here in this column, and then these are the non-faces, that left-right spatial task. My non-exposed infants are in red, and my opiate exposed are in orange. And this bar represents 50% as far as their novelty preference. So remember, that's our comparison point to see if they're discriminating between that novel image and that familiar image. So you see that my non-exposed images in both cases, or non-exposed infants in both cases, are discriminating that novel image. But what you're seeing in my opiate exposed is that they're not. Their performance is right around chance. It's not significantly different, showing that they're not able to remember or pick up on those subtle differences between those images. And what we end up with, if you look at the ANCOVA, is just a main effect of group. So we're seeing a non-exposed, just on average between both studies, have a higher novelty preference score than our opiate exposed. And if you remember, the novelty preference scores are related to later academic achievement, where if you're seeing higher scores, those are correlated with then higher scores at school age. So that's something that could be pretty integral if we're already seeing these lower scores within the first week. You know, is that something that's going to persist later on, or is this something that we only see within the first few hours? So that's one of the things I'm hoping to look at in the future, is to make this a longitudinal study and follow these kids throughout at least the first year. So after controlling for some of those differences, SES, infant age, and head circumference, we found that non-exposed infants, their preference scores were greater than the opiate-exposed infants, suggesting that there's some sort of an association between their processing, their spatial processing abilities. I ran some supplementary analyses, but I'm going to skip those for time and get into the limitations, because I know you guys are all probably itching to talk about those, because I know that there are some. But I ran into a lot of difficulty matching my groups, and I kind of acknowledge that and know that that's something that I'm going to work really hard to try to address in the future, but I'm also realistic in knowing that I'm not going to be able to perfectly match my non-exposed and my drug-exposed groups. I can do a better job, but understand that it's going to be very difficult to do. Now, these data are also all correlational, right? I can't experimentally manipulate who's getting opiate exposure and who's not. So that needs to be something that you guys remember too, that I'm just showing associations, that there's a link between. So we're not saying that it's causing or affecting those abilities, but there is a correlation. Also, I've got such high variability within my opiate-exposed sample, it could be leading to subtle differences within that group that I need to examine more too. And so, as I've been doing a lot of these talks and presenting to other researchers, I've learned that one of the big things that I would like to do in the future is to actually have studied my opiate-exposed groups at multiple time points. So right now I've got infants who, some of them are receiving opiates for treatment at the time of test, not just prenatally. Some of them haven't received them yet, so that's part of that variability. So ideally it'd be nice to study these infants at those various points before they've been treated, so before they've maybe started to withdraw, while they're withdrawing, and then after they've been discharged from any sort of treatment. And that's part of the longitudinal aspect I'd like to advance within these studies in the future. So a lot of ideas for kind of moving forward, and I can kind of put up all of these ideas at once, and then I'll probably just ask for questions since I'm running out of time. So disentangling the effects of NAS from the effects of prenatal opiate exposure, that'll get at those multiple groups. And then potentially correlating this novelty preference with different types of measures. So those standardized assessments I talked about earlier, various physiological measures, motor development, looking at tasks more on attention, so getting out of just understanding of is it just a spatial processing deficit? Does it have to do with attention? Are there other aspects of cognition that may be impaired? And then getting into more of the social competence too, looking at other aspects of social stimuli. So I'll kind of cut it off there and ask for any questions or comments, and we'll go on away. Okay. Yeah.
Computerized then, or are you actually trying to measure that actively?
Right, so when I'm kind of tracking the attention of the infants during the tasks, if I'm studying older infants, so there was that one task where I had the target that was flashing, you saw the red gaze. That was actually done by the computer. That was done by an eye tracking system. So that's done in that fashion. With the newborns, and some of the other age groups I presented, that coding and that behavioral of coding if they're where they're looking is done offline by hand by different individuals. So that's just kind of timing how long they're looking, kind of going frame by frame through there and searching. Yeah, so there's, I think within the research lab at the University of Kentucky, we usually had around 5 or 6 individuals coding data for various studies. But then every study we code about 25 to 30% again for that inter-rater reliability, which is typically very high, above 90% or 0.9.